All right, how about now? Good? Okay, great. That's good. Bhumika is also here, so good place to start recording. So that's fine. So what we are going to do is learn a little bit about this. Now, your reading was chapter 4 and then chapter 6 for these topics. I don't know how much you were able to read these two chapters, but I'm hoping at least once you would have been able to just skim through. So we are going to learn about Z-scores. Now, you may have heard what is a Z-score, because for A-levels to get into university or now they are using these Z-scores, right? So now we need to understand what that is. Do you have any idea? Z-scores? When they talk about Z-scores, what it's all about? No? No idea? Okay, so
no idea, but just read the chapter that you gave.
Right. That's okay. So it's like this. Now, when we let's say we have standard measurements, right? Now, I'm taking these examples from the chapter itself, so that hopefully, if you have read it once, it might come to remembrance, right? So when you have like a weight, you want to calculate the weight, right? And all the weights you want to calculate in kilograms, right? And all the distances you want to calculate in meters, right? So what do? If you have a distance in feet and inches, you have to divide that by, the number of meters, that particular measurement, to convert that into meters, so that we all understand this particular distance in meters or in kilograms. So to turn pounds into kilograms, we divide by 2.2, right? So this is a very similar thing that we are doing in statistics, that let's say, so standard deviations are the standard measurements, right? So in the book, you have a score 21 above the mean, above the mean, a score of 21. And if we know the standard deviation is 7, we can say that the score is 3 standard deviations above the mean. Is that clear? You simply divide the score by 3, the 7, and you get 3. So you know how many standard deviations. It's the same principle where you're standardizing the distance, let's say 2 kilometers. Your house is 10 kilometers from the city of Colombo, or 20 kilometers from the city of Colombo. So we are trying to see a particular score, how far is it from this mean, from the average, right? And to do that, the standard measurement, the standard measurement that we are using is this standard deviation. Are we recording this? Is this being recorded? Yes. Okay, great. Right. Now, when, let's say, on the other side of the scale, if we have a score, let's say 14, this is from the book, 14 below the mean, right? A score which is 14 below the mean, and we know our standard deviation is 7. So how do we now say it in a standardized form? It's 2 standard deviations. That person has scored 2 standard deviations below the mean. Is that agreed? Everybody agreed, right? I don't see everybody in here, but if you're not agreeing, just say something, because I'm only seeing Jito in my screen. Not sure, but the others, if you don't understand this particular concept, just say something, because I don't see you, right? Okay, so I'm since everybody is very quiet, I think I'm going to assume that you understand. If you have a score of 21 above the mean, and you know that the standard deviation is 7 for that set of scores, you can interpret this 21 as 3 standard deviations above the mean, right? So that's how you would say it. So basically you're bringing it into a standardized form, right? So now so unlike these, these other measurements, right? The number of standard deviations apply no matter what is being measured, right? Whatever you measure, this number of standard deviations is what you call a universal scale of measurement, right? It's a number of standard deviations. Now, for each scale, the standard deviation may be different, but how many standard deviations above or below the mean is a universal way of understanding what a particular score means, right? So now, when it comes to Z score or Z score, this is nothing more than the number of standard deviations a particular score lies above or below the mean, right? So what do we do in order to work out the Z score, right? We need to know the mean and we need to know the standard deviation, right? Because the Z score is nothing other than the number of standard deviations, right? A particular score lies above or below the mean. That's it. That's what a Z score is, or an Z score, right? So that is why sometimes Z score is termed as standard score, right? Because it is expressed in a standard form. So far so good. If it's not understood, just say something. I will go through that again. But when we do our exercises, I think we will kind of understand it a little bit, get a little bit more clear on that, right? So, okay. So now, how does this Z score work, right? How does the Z score work? So now I'm going to show you my new toy, my tag, hopefully. This will work, and I have a nice pen to write. Let's say you have your, give me 1 second. So can somebody bring up on screen this particular chapter 6.2. I wonder whether anybody has that in their screen. Is it possible? Because I can't see that, and
I'm trying to open it.
right. Yeah, that's okay. Great. If you can get that and read out some numbers, it will be very easy for me. I think page 81 in that book. So we are going to kind of figure out this Z score, right? So
it's taking time for me. If anyone has it access, then can read.
Right.
Sorry, okay. Give me a minute.
That's okay. That's okay.
On my phone, so it's taking a bit of time.
That's all right. We'll just put in the formula x minus x bar divided by the standard deviation. This is basically how we calculate the Z score, right? So here, what is x? X is the score, right? X is the score, right? X bar is the mean of that particular set of scores. And SB is the calculated standard deviation, right? Now we know how to calculate the standard deviation because we know if we have a set of scores, let's say we have 5 scores, we know how to find the mean of that 5 scores and then find the deviation from the mean. You minus the mean from each score, square that, add up the squared totals and get the total, divide that by 1 minus the total number of scores. So if it's 5 scores, 5 minus 1 is 4, and there you get something called the variance. Now variance, the square root of that variance is the standard deviation, right? So it's quite easy to find the standard deviation. So here we are trying to get this standardized score, which is the Z score. And how do we find this? We have to find first the distance from the score to the mean. That is why we say x minus x bar, that is the distance between the particular score to the mean. And then you divide it by the standard deviation to see how many standard deviations is it far from this particular place. The same way is how you find out how many kilograms is 10 pounds, right? How many kilograms is 10 pounds? You divide it by 2.2, right? So here we have that example in the book. We have to convert the age of a 32-year-old. 32-year-old. Does anybody have it? Given that the mean of the set of the ages is 40. Mean is 40 and the standard deviation of the age is 6 years. Right? So we have the mean is 40. Right? SD is 6. So now we have to find the standardized score or the Z score of a 32-year-old. Where does he fall into in the grand scheme of things? A 32-year-old. So 32-year-old Z score would be 32 minus the mean is 40, correct? 40 divided by 6. What is that? 32 minus 40 would be minus 8. Divide by 6, what do you get? Minus 3. What do you get? Um, 8 divided by 6 is 1.33. Correct? 1.33? That's the answer that we are getting, right? So how do you say it? Is everybody agreed with 1.33? Usually give it to 2 decimal places. Minus 1.33. It's a negative sign. The value is a minus. Now we can't forget the what is it? The plus minus, the sign of it. We can't forget that when you're calculating the Z score, because it tells you whether it's below the mean or above the mean, right? That's your minus is very important here, right? So what it tells us is that the 32-year-old is 1.33 standard deviations from the mean age of 40. Okay. So the minus sign says that the 32-year-old is obviously younger than the mean age, right? That's what the minus sign has given us. 32 is obviously younger, lower than the mean age of 40, right? So a plus sign or a no sign, okay, would mean that it's older or higher. That's easy enough, right? So now would you know what to do to calculate the Z score? It's pretty easy. If you're given a particular score, a mean and the standard deviation, this is how you simply calculate the Z scores. right? So for example, for A-level students, when they get their Z score, what have they done? They have taken as X that particular score of the student and reduced the average score that everybody has got. You know, whatever everyone has received for that particular exam, they have reduced the average to see the distance between the average and the student's score. And you're dividing it by the standard deviation, which is already worked out, to see whether that student is within a certain standard deviation. Z score has to be maybe higher than one standard deviation, because all the average kids will be within one standard deviation, right? And that percentage is about 68% of the people. So how many kids would go to university in Sri Lanka? What is the percentage of people who will go to university in Sri Lanka? 5%, 10%? I really don't know that. So they will see what is that, how much of the Z score is needed to be within that percentage. Do you understand this now, this concept of Z scores? It's because the Z score tells us that we are so many standard deviations from the mean. That's basically what the Z score is saying, right? So now in the next page, in page number 82, it talks about the use of Z scores. We need Z scores. Otherwise, it wouldn't prevail for so long. Why do we need Z scores, right? There is a very nice example in your textbook. The student, psychology student, has done it's an unpublished thesis. This is an unpublished research the student has done, okay? So you are not going to find it in Google Scholar or any other ResearchGate or wherever. This study you cannot find it. I tried and tried and tried. I also could not find it. It's not even there in the university library because it's unpublished, right? So unpublished, how do I know? It is in the references section of this textbook. It says very clearly, it's a student's research and it's unpublished. So very unlikely that we can have access to it. So what he has tried to do is he's tried to get the effect, okay? He wants to know, the student wants to know how much anxiety, right, is experienced by the young tennis players, child tennis players, and how much, double faults they play, right? And is there a connection between their performance and the commitment of the parents, right, to their tennis development? All right. So, that is what he wanted to find out. Now, how do you measure these things? You can't simply go and measure commitment. You can't ask each parents, go to parents and ask, can you say how committed are you? Yeah, on a scale of 1 to 10, can you say how committed you are? Everybody will think of their own commitment. You know, if both parents are working and if a parent is giving 100% of, their whole weekend, they will say, oh, I'm at a 10. You know, I'm so committed, because she can give the whole weekend, but a mom who's not working will give 5 days of the week. So she will also say 10. So then, does it make any sense to get the commitment level from that kind of scale? It does not make any sense, right? So you have to have a way of measuring this commitment. So this student, what he did was he formulated about these, 6 different questions to ask. How much money do you spend per week, right, on the child's tennis coaching? How much money do you spend per year on the tennis equipment? How much money on the tennis clothing? And how much miles do you travel right? For tennis events. And how many hours per week on average do you spend watching your child play? And how many tournaments does your child participate in a year? Now, you can see with these questions, these are very, very measurable things, right? When you ask how many miles do you travel for the week or for the year or for the month, of course you know how many miles you travel, right? If I'm traveling from Moratuwa to SLT, I know it's 16 kilometers. So if I'm taking my child to SLTA like 3 times a week, I know, okay, coming back 32 kilometers into 3, it's about 96 kilometers a week I'm traveling, right? So, and in addition to that, I know how much I travel, how much we are on the road going back and forth to school practice. So these are all measurable, right? But guess what? Each of them have different measures. One is measuring time, another one is measuring distance, another one is measuring money. So all different measurements. So this is where we do the Z score. We convert all of it to the Z score. Once we have an Z score, then everything is measured. We know there is one standard measurement for all of these different measurements, right? So that's how you get the total parental commitment, right? So now, of course, the SSPS will do this for us very easily. We will see later on how SSPS will calculate Z scores, right? So this is something, now what we did was to figure out a use of Z scores in daily, psychology research, what is the commitment level. So the very important thing is in this particular students' research, right? Important thing for us to know is that last paragraph in that, it's actually in page 83. It says in your textbook, this was an excellent strategy since this measure of parental commitment was the best predictor of a child performing poorly in competitive situations. The more parental commitment, the worse the child does in real matches compared with practice. So I think maybe that is why it's not published. I don't know, but in Google Scholar and even in the online libraries, there is a plethora of research giving a lot of positive views on parental commitment and tennis achievements in junior tennis players. So there, I checked a few of them which have been cited very highly. I mean, 300, 500 times citations. So people cite good research, not just any research. So if some research is appearing and the citations are not there, chances are somebody has already checked it to see it's not done properly. So I have checked the ones that have been cited very well, but they are not actually taking into account this particular parameters of this study. So this is a very unique study that has happened, right? So something to, we shouldn't be going around saying, oh, too much parental commitment will make them perform poorly. That's not the case. But the pressure from parents actually make young children perform badly in competitions. Not practice times, but the parental pressure can be too much. So most of the studies that are published talk about, the understanding part of it, the parents' understanding that goes with the commitment. So when parents are more empathic and, with the child and they are not very vocal, children do perform very well when they know that mom and dad is, they got their back, and they're sitting there. It's a nice thing to have, as long as mom and dad know their place and sit quietly and enjoy, show that they are enjoying being there. That's what the published research is talking about. So that commitment is necessary for a child to perform well in tournaments, right? In actual competitions. Right. So interesting stuff this is. Okay. So now we are going to do a little, I'm going to send you a quiz. All right, time for a quiz. So let me, first of all, I will put it in the chat. So if anybody can pick it up from the chat, do that. Otherwise, I'm going to send it to you quickly in the WhatsApp. Give me 1 second to take it out. So I'm going to